Okay, so we will talk about normal form in context free grammar. So, there are two normal form, one is Gabic normal form and one is Chomsky normal form, CNF, GNF. So, let us start with the normal form, what are those normal forms. So, suppose you have given a context free grammar G, which we know it is V T P S, where V is the set of all variables and T is the set of all terminals, and S is the special variable which is called start variable. S belongs to V, S is a starting variable or start variable, and P are the set of all productions. I mean, these are the rules, and following these rules we start from S and we derive the expression, and the P will be of this form. P is consist of all the rules of this form, this where A is a variable and alpha is coming from like this. Okay. So, this type of productions we have. So, a variable is going to some x 1, x 2, x k say, where x i's are either variables or terminals, or it could be epsilon also. So, this type of productions are there in our P, the production set. Okay. So, now we will define two set of two form of normal form. One is CNF, other one is GNF. So, this is called Chomsky normal form. Chomsky, yes, Chomsky normal form. In short, it is called CNF. Okay. So, the normal form means this is the grammar we have V T P S. Normal form means this P, the productions will be in some particular form. So, for this case production will be of this form. A is going to alpha, or A is going to A, or A is going to B C, where B C are two variables and A is the terminals. So, all the productions. So, P consists of this type of productions only, where A belongs to a terminals and B C are from the variables, capital C. This is capital C. So, if all the productions are of this form, and if epsilon is belongs to the language G, then we have a production S is going to epsilon. This production will be there in P. Otherwise, if epsilon does not belongs to this, then this is, because this is A, this is not a T star, this is a terminals. So, if our production, all the productions are of this form, then we call this is a CNF, Chomsky normal form, like and this is either all the productions either will be in this form. A is going to some terminals, or A is going to the product of concatenation of two variables. Okay. So, we can take an example, or if epsilon is a string which is generated by this grammar, then we have a rule S is going to epsilon in P. So, this is called Chomsky normal form, CNF. If our all the productions are of this form, then the grammar is called in Chomsky CNF. Okay. We can take an example. So, example of So, we take a grammar like this. We have 3 variable a, b, c, and we have terminal say a, b, small a, b. P we have to define, and S is the starting variable. Okay. Now, let us define the rules. Rules consist of this set. Say S is going to A B or epsilon, because we here we want to generate epsilon as a string of string language string which is generated by this grammar. This is 2 rules. A is going to A and B is going to B. That is all. So, if you check all the grammar, all the rules, all the productions in this grammar, all the productions are of this form. Either a variable is going to a variable say x is going to a terminal, or x is going to y z, the 2 variables, and if epsilon is there, that means epsilon will be generated by this. So, this is one example of Chomsky normal form. But if we take another language with the same variables and the grammars are like this, rules are like this. So, this is Chomsky normal form CNF. But let us take an example which is not in CNF, like this one. Suppose we have a rule S is going to A B C, A C, A is going to A, B is going to B, and capital C is going to small c. Here sigma is A B C. Now, this is not in CNF. Why? Because this is having 3 variables. For CNF, we need to have only 2 variables. So, CNF will be of this form, A is going to B C type of thing, or A is going to some terminal. So, this is the only form for CNF, but this is not in this form. Even this one C, this is also not in this form. So, this is not a CNF, but we can make this to be CNF. Given any grammar, we can convert into a Chomsky normal form. So, that we will see. Before that, let us define the another normal form, which is Gabek normal form GNF. Okay, so this is another normal form, Gabek normal form, GREI. GNF. Okay. So, when we say a grammar is in GNF, again these rules are in particular form, like if it is we have a grammar like this, and suppose the rules are of this form. P consists of all the A variable is going to alpha, A alpha, where A is a terminals, but alpha is a string of variables. Alpha is a string of variable, then it is called in GNF. This is called is, for example, if we take a grammar like this. So, S is P suppose we have a 3 variables, say S A B, S A B, and we have A B. This is the T, P and S. And suppose this P consists of these rules. Again, if epsilon is belongs to L of G, then we have a rule S is going to epsilon, that is there. Okay. Suppose we have a rule like this, S is going to say some A B or epsilon, and A is going to A, B is going to B. This is in the GNF form, because this is S is going to A alpha, alpha is just string of variable, alpha could be epsilon also, because in this case A is going to A means here alpha is epsilon, but epsilon is allowed. So, that is a valid form. So, this is one example of GNF. So, we will see more on GNF in the next class, but today now we will discuss how given a gamma, how it can convert into a CNF. So, reduction of gamma to the normal form CNF. So, that we will do now. Reduction to CNF, that means given a gamma, how we can convert into a into the normal form. Like normal form means there are two normal form, but we will discuss the first one, the CNF first, then we will discuss the GNF given any gamma. Okay, so how we can do that? So, for example, in suppose we have taken this example, S is going to ABC or AC, or A is going to A, B is going to B, and C is going to C. Okay. Suppose this is our given gamma, and we need to convert into CNF. This is not in CNF, because this CNF means what? CNF means the every variable should go to either a terminal A or product of two variables. This consists of no terminals. So, this is called, this is the CNF normal form, but here this is okay, this is okay, this is okay, but this is not okay, because it consists of a terminal and a variable. So, that is not allowed in CNF. So, this is the CNF, and this is also not, this is capital C, this is also not okay. So, these two are not okay. So, we need to somehow convert these two in the CNF with the help of some other variables, like that we are allowed to, we can introduce some other variables to do that. So, how to do that? For example, how to convert this? S is going to ABC, how we can convert in CNF? With the help of some, we can introduce some other variable here. So, what we can do? We can introduce a second variable E, like E or D, anything. Yeah, we can introduce a E here, or so S is going to AE, like this will be replaced by, this will be replaced by, this is same as S is going to AE and E is going to BC. So, this production will be replaced by two more production with the help of another variable. S is going to AE and E is going to BC. Okay. And this is okay. Now, this is CNF, this is CNF form. Now, also for this one, like S is going to AC, what we can do? We can also take help of some other variable D. So, S is going to DC, capital C, DC, and D is going to A. So, this is the way we can. So, this is in CNF, this is in CNF. So, both are in CNF. So, basically this is the grammar we have given. So, where G is V consists of V, which is ABC, and we have a T which is also small ABC, and then we have ABC and S also. We have S, we have P, and we have S. Okay. Now, this will be replaced by the grammar G1. This is G grammar. This will be replaced by the grammar G1, equivalence grammar G1, which is in the normal form G1, which is V1. T will be same, P1, S will be same. We are not changing the S. Now, V1 is having all the new variables along with the old variable A, B, C, S, and we have introduced D and E. And T is same, S is same, only P1 will be changing. First of all, we will put all the grammar, all the productions which are in the already in the normal form, that we will first put, like A is going to A, B is going to B, C is going to C. These are already in CNF. So, we will first put those rules, and next we are going to replace this by S is going to, just now we have seen AE, and E is going to BC. This one we have replaced, S is going to DC, and D is going to A. Okay. That is all. So, this is the corresponding grammar for this, and we can see that this language generated by G will be same as language generated by G1. Okay. So, this is through an example, but in general we can prove this, we can show these are equivalent. So, how to show this? So, that we will try. So, given a grammar, how we can reduce to a normal form, particularly CNF. Okay. So, we have given the grammar G. Now, so P will be of this P, this is any grammar. So, it is not in a normal form. So, we will construct a grammar, another grammar G dash, we may introduce some more variable, terminal will be same, terminal set will be same, S will be same, we are not changing the S. Okay. Now, first suppose we have given a rules like this here, A is going to some x1, x2 to xk say. Now, suppose this is a rule. So, some of the xi's will be coming from T and some of the xi will be coming from V. So, some of the xi's are the variables, some of the xi's will be at the terminals. Now, we want to, if it is terminal, then we want to bring it to a variable. We want this all xi should be a variable, because we will see that. So, for that, suppose this xl is a terminal, say xi is a terminal, xi is here ai. Then what we do? We just replace this. This is equivalent to two rules, x1, x2, xi minus 1, and then C of ai, capital C, C of ai, or we can say in the note it will be this notation, C of ai, then xi plus 1 dot xk. So, C of ai, we have introduced a new variable here. So, our V will be now, V prime will be V union of C of capital C of ai, some notation, some new variable we are going to introduce, and C of ai is going to Yeah. Okay, this is okay because this is allowed in the CNF. Only thing in CNF we should not have this combination of the terminals and the variables is not allowed. So, that is why if there is a variable, there is a terminal, we have to replace that by variable and that variable will go to that particular terminal. So, this way we do. So, if we have more such terminals, then we will do this replacement like this. Okay. Now, finally, we have the form like this. A is going to some y1, y2, yk, and where each of these y's are variables after doing this job, and say remaining are in of this form, CNF form, remaining rules including this newly added rules. Okay. Now, these are all variables. Now, how to convert? Because we know we have to convert this also, because we know that our CNF is of this form. A is going to BC, only two variables. Here we have many variables. So, how to transfer? So, this will be again transferred as this. I will follow the notation like this. So, A is going to yes. So, A is going to say some y1 d1, this whole thing. Now, d1 is going to y2 up to yk, but then again we will take help of some d2. So, we are keep on adding this. So, now this v prime is v prime union d1 d2, how many are there? So, d2, then d2 will be going to d2 is nothing but d2 will give me d3 like this. So, dot dot dot, then so lastly we have y k minus 1 and y k. So, we have d k. So, d1 is going to this. So, d k minus 1 is going to d k plus 1. No, d k is going to y k minus 1 and y k. So, like this we will do. Okay. So, if this is not even, then we can have y k, then that is going to epsilon. So, this is the way we first convert everything into the variable, and then once we have a string of variable, that we will replace by this is the way. So, we will take a quick example. We will take a quick example. Okay, suppose we have the grammar like this. A is going to AD, sorry, S is going to AD, A is going to AB or BAB, and B is going to B and D is going to D. So, this is the grammar. So, we have corresponding variables S, A, B, A, B, D. Okay. So, now first we have to remove the null and unit productions, because that is the redundancy we have. So, we can remove the nulls and unit production, but here there is no null and unit production there. Okay. Now, what we do? So, we can check which are in the already in the this CNF. So, first of all, B is going to B and D is going to D, these are already in this form. So, we will add this into this new rules, and then we take this one. So, this one is mixture of variable and terminal. So, what we do? We just replace this by this gives rise S is going to C A A B, where C A we are going to introduce there. So, V prime is V union C A, C A is the new variable. So, now this is all variables. Now, we introduce S is going. So, this is we can do it in second phase, where we have all variables, then we can do it, but here also we can do, but anyway we can try this. So, yeah, so anyway this we can finish it up. So, this is the rule and C A is going to A. So, this we can add in P prime, and for this we have to take help of another variable. S is going to some this C A and some D 1, and D 1 is going to A B. So, these two combined will give us this. Okay. This is done. Now, we take these two are not in normal form. So, A is going to A B. So, this we can do one thing, we can change this to a variable, another variable. So, this will replace as A is going to some W 1 B, and W 1 is going to A, like this. And similarly, we can do it for this also. And every time once we are introduce a new variable, we need to add this in this variable set. So, we have to add D also, D 1, D 2 like this. So, again A is going to be A B. So, this will be replaced by, like we have to change this to variable. So, this is going to be C B A B, and C B is going to B. So, this we have to add to the rules, and here we have to add this C B here. Okay. Now, this is okay, but this is not okay. So, for this we have to change this to C B, some if we have not used W 2 we can use here, and W 2 is going to A B. So, these are we are going to add in P prime, and V prime will be V prime W 2, like this. So, we will keep on doing this and we get the this thing. Yeah, ultimately we will get the everything in the normal form. Okay. So, and we can prove that this the reduced grammar, like if this is the grammar V P V T P S. Now, this is reduced to the grammar V prime T T prime T P prime S, and we can show that this is G and this is a G prime. We can show that grammar generated by G is same as grammar generated by G prime. So, the proof will be in the lecture note. Thank you.